let's look at some examples now of some relationships, graphs of relationships, and what their R value would be. So in figure 2 in number A, you can see that it's a perfect positive relation. And so R equals 1. We know it's perfect because those points line up on a perfectly straight line. If we look at B, this is a strong positive linear relationship. The R value is about 0.9. We can tell it's strong because while it's not perfect like in A, it's still pretty close to a straight line. If we were to approximate a straight line through there, all of the points, or most of them, are not very far away from that line. When we get to C, if we try to draw a straight line through there, you can see that the points are much further away from that line. So that's a moderate positive linear relationship, and its R value is around 0.4. If we move on to D, that's a perfect negative linear relation because we can draw a straight line through there, and we know it's negative because as the horizontal values get bigger, the vertical values are getting smaller. Looking at a strong negative, it's the same thing as a strong positive. It's just decreasing as the line goes along from left to right. And the same thing with the moderate negative linear relation. If we look at G, there's no linear relation, and that's R being close to 0. If we look at H, that's also no linear relation because the R is close to 0. But this one, we would say it does have a non-linear relationship. But that's beyond the scope of this class. So let's try to match some linear correlation coefficients to some scatter diagrams. So here we have 4 scatter diagrams and 4 different R values. So using that table up above, not the table, but these pictures in figure 2, you should try to do this example on your own. So put each R value with which graph you think it belongs with. Pause the video and do that, and then restart the video and you can check yourself. If we look at the top left graph, we can see that as the horizontal variable is getting bigger, the vertical variable is also getting bigger. So we know it has to be one of the 2 positive correlations. And since these are much closer to being all together on a straight line, we would say this one has an R of 0.9, probably. If we look at the top right, this one also has positive association because as the horizontal variables get bigger, so do the vertical values of the variable. But you see, it's a little bit more scattered. If we tried to draw our straight line through there, the points are a little bit more scattered off of that line. So that one's probably an R of about 0.7. I'll go back and draw our line on the other one too. If we look at the bottom left, this one's clearly negatively associated. As the horizontal values get larger, the vertical values get smaller. And if we were to try to draw a line approximately through there, yes, I realize that's not a straight line, pretend it is. You see the points are fairly widely spread away from that line. That means we probably have an R value closer to 0, which would be negative 0.2. Well, actually, I lied. These are not as far apart as the other ones, so this is probably negative 0.6. These are more widely scattered even than the previous ones, so they're the R of negative 0.2. Let's end this video here, and when we start the next video, we will talk about how to actually find the linear correlation coefficient using technology.